The vertebrate retina is inverted in the sense that the light-sensing cells are in the back of the retina, so that light has to pass through layers of neurons and capillaries before it reaches the photosensitive sections of the rods and cones. The ganglion cells, whose axons form the optic nerve, are at the front of the retina, therefore the optic nerve must cross through the retina en route to the brain. In this region there are no photoreceptors, giving rise to the blind spot. In contrast, in the cephalopod retina the photoreceptors are in front, with processing neurons and capillaries behind them. Because of this, cephalopods do not have a blind spot. Although the overlying neural tissue is partly transparent, and the accompanying glial cells have been shown to act as fiber optic channels to transport photons directly to the photoreceptors, light scattering does occur. Some vertebrates, including humans, have an area of the central retina adapted for high-acuity vision. This area, termed the fovea centralis, is avascular, and has minimal neural tissue in front of the photoreceptors, thereby minimizing light scattering. The cephalopods have a non-inverted retina which is comparable in resolving power to the eyes of many vertebrates. Squid eyes do not have an analog of the vertebrate retinal pigment epithelium. Although their photoreceptors contain a protein, retinochrome, that recycles retinal and replicates one of the functions of the vertebrate RP, one could argue that cephalopod photoreceptors are not maintained as well as invertebrates and that, as a result, the useful lifetime of photoreceptors in invertebrates is much shorter than in vertebrates. Having easily replaced stalk eyes or retiny rarely occurs. The cephalopod retina does not originate as an outgrowth of the brain, as the vertebrate one does. It is arguable that this difference shows that vertebrate and cephalopod eyes are not homologous but have evolved separately. From an evolutionary perspective, a more complex structure such as the inverted retina can generally come about as a consequence of two alternate processes, an advantageous good compromise between competing functional limitations, or as a historical maladaptive relic of the convoluted path of organ evolution and transformation. Vision is an important adaptation in higher vertebrates. A third view of the inverted vertebrate eye is that it combines two benefits: the maintenance of the photoreceptors mentioned above, and the reduction in light intensity necessary to avoid blinding the photoreceptors, which are based on the extremely sensitive eyes of the ancestors of modern hagfishes.